Hey guys, and welcome back to the channel. A couple of weeks ago I showed you this Pentium 200 MMX, and I also showed you a video on a Cyrix 6x86 CPU find. Now for this video I wanted to do some kind of head-on comparison between the two CPUs. This Cyrix 6x86MX CPU with a performance rating of 200 versus this Intel Pentium MMX CPU running at an actual clock frequency of 200 MHz versus the 150 MHz of the Cyrix CPU. So let's do a quick side-by-side comparison. As you'll notice, the Cyrix 6x86MX runs at a core frequency of 150 MHz as opposed to the 200 MHz on the Intel Pentium 200 MMX. The Cyrix has double the level 1 cache as the MMX CPU does, and it was priced significantly lower than the Intel counterpart. Now for me, these are two great CPUs from a great era of computing, 1997, 1998, when 3D games became very popular, and this Cyrix offering was a pretty low budget compared to the Intel offering. So this was the era of socket 7 CPUs, where another big player, AMD, also had its fair share of interesting CPUs like this K6, this one clocked at 266 MHz. All of them could be fitted on a socket 7 mainboard, and this was really interesting because socket 7 mainboards had a very long lifespan. You could hook up all kinds of CPUs on them, and you didn't have to stick with standard socket 7. You also had something like super socket 7 with added AGP ports, 100 MHz frontside bus speeds, and ATX compatibility. We didn't have to immediately upgrade to a slot 1 based architecture like the Intel Pentium 2. So in this video we're also going to be playing some games like this Need for Speed 2. We're going to play some Quake. We're going to try the 3DFX GL Quake as well as the software rendering. We're also going to be running the DOS benchmark pack, the excellent pack from Phil's Computer Lab, to run some DOS based benchmarks. We're going to also do some Windows-based benchmarking using 3D Mark 99. And look at some results. But back to the star of the show, which is this IBM or Cyrix 6x86MX PR200. But before we look into more detail on this specific CPU, I did want to briefly go over the different CPUs that Cyrix or IBM put out there. So starting with this Cyrix 6x86 CPU, the original 5th generation CPU from Cyrix. So this was marketed as a cheaper alternative for the Intel Pentium, promising the same level of performance. It wasn't 100% compatible with the Pentium instruction set, but it was fully compatible with the x86 instruction set. Now, despite the P166 naming convention, this CPU was actually running at a core frequency of 133 MHz, produced by a board frequency of 66 MHz and a fixed multiplier of 2. Now for marketing purposes, and because this CPU was inherently faster than a Intel 133 MHz, Cyrix introduced the P rating or the PR rating, which is a performance rating allowing Cyrix to compare its CPUs with the Intel counterparts. So this CPU was actually comparable with a Intel Pentium 166 MHz CPU. So like the original Pentiums, the non-MMX CPUs, this is a single voltage CPU, meaning that the core voltage of this CPU matches the I/O voltage of the computer, in this case somewhere between 3.3 volts and 3.52 volts. This CPU also generated lots more heat than its Intel counterpart. So next up came the 6x86L, or the low power version of the previous Cyrix CPU. This solved much of the heat issues that the previous generation had. It also lowered the core voltage from 3.3 volts to 2.8 volts. It introduced the split power plane design, much like the Intel MMX CPUs. So the core voltage of the CPU was lower than the I/O voltage. It shared much of the same characteristics as the previous generation. So it uses the same front-side bus speed of 66 megahertz, a multiplier of 2 or 3. It also had 16 kilobytes of level 1 cache, but used the split voltage design, meaning that the core voltage of the CPU would run at 2.8 volts instead of 3.3 volts. Sometime later, the 6x86MX was released, and this one added the MMX instructions to the CPU, improved the Pentium compatibility, and it quadrupled the level 1 cache to a whopping 64 kilobytes, which was double the cache of the Intel Pentium MMX. MX variants also came with higher clock frequencies, all the way up to a performance rating of 266 megahertz. And despite the previous CPUs having a fixed multiplier of 2, the MX variants also had more flexible multipliers. Cyrix did have to increase the voltage of their CPUs from 2.8 volts to 2.9 volts for stability reasons. Also, some CPUs like this PR200 originally came with a 150 megahertz core frequency, so a 75 megahertz frontside bus with a clock multiplier of 2, but then later, as the manufacturing process improved, they were managed to bump up the core frequency to 166 using a 66 megahertz frontside bus with a clock multiplier of 2.5. And it was also Cyrix that introduced us to the 75 megahertz frontside bus speed, something that was then followed by other CPU manufacturers like AMD. Now, later revisions of the 6x86MX were called the M2. So they were basically the same thing, but they did offer the CPUs at higher clock speeds. However, they were very late to market with this, and at that time people had moved on to more powerful CPUs like the Intel Pentium 2 and the AMD K62. But back to the little test setup I have here. So I have the 3D Blaster video card, sound card, and networking card. I don't have one of these fancy open bench cases, so I'm going to be using this. I've also added a PC speaker so that I get some feedback. Have a power supply, some hard drives, and some video capturing stuff going on here. So it's very important to hook up a PC speaker to your mainboard just to know what's going on when the system isn't booting. I also added a sound card as we're going to be playing some games. It's always nice to have a little bit of sound. In the video department, I've opted for this 3D Blaster Banshee. So this is a socket 7 mainboard. It only has PCI. And I also added a networking card, this 3COM networking card, as I want to be able to transfer files from into the system. So let's take a look at the mainboard and the CPU. So this is a standard socket 7 mainboard, the IBM 6x86MX PR200, clock multiplier of 2, and a frontside bus of 75 megahertz running at 2.9 volts core, tucked away in this socket 7. Now, when configuring a new CPU on a motherboard, you always need to have the motherboard documentation at hand. And there are always two things that you need to configure. You're going to be configuring the CPU voltage, which will be different for different types of CPUs. And you also want to configure the CPU speed, which is always a combination of the frontside bus or external bus and some clock multiplier or frequency ratio. So in more modern systems, you would typically configure this in the computer's BIOS, but this socket 7 mainboard, as a lot of socket 7 mainboards, has a very basic BIOS, which doesn't allow you to configure stuff like voltages or frontside bus speeds or clock multipliers. So everything is done using jumpers on the mainboard. So let's start with the CPU voltage selection. So it's very important that first we decide whether we're using a single voltage or a split power plane design. So for this 6x86MX, much like the Intel Pentium MMX CPUs, we're going to be going for the split power plane. So that means that the core voltage of the CPU runs at a different voltage as the I/O voltage. So here it's just a matter of looking up our CPU or voltage. In our case, it is 2.9 volts that we need to set for the Cyrix 6x86MX. Now, sometimes the documentation might be a little bit out of date in the sense that perhaps this Cyrix CPU wasn't already out yet. So we just need to look at the actual voltage number, which is 2.9 volts. As you can see here, it doesn't even mention the Cyrix MX, but these are the jumper settings that we need to use for our Cyrix. So jumper 8 here specifies that we want the split power rail design. And jumper 9 here sets the 2.9 volt core voltage. And you can actually check this core voltage using a multimeter. So here I have hooked up the main board to a power supply. And using this chip here, I can measure the core voltage which is provided to the CPU. And this is indeed 2.9 volts as the Cyrix 6x86MX supports. So if I move the jumpers here and I opt to use a different setting, here I have opted to 2.8 volts, I should get 2.8 volts instead of 2.9, which is the case. I can also set it to 3.5. But for this case, we're going to go for the 2.9 volts. Now that we've set up the core voltage correctly, it's time to look at the actual CPU speed. For that, we need to look at this table and find our Cyrix 6x86MX PR200 CPU running at a bus speed of 75 megahertz. Now the CPU that we are using here is a PR200 with an external bus speed of 75 megahertz. So the first thing we'll do is set jumper 6 in the correct position. Notice that it was set to a 66 megahertz bus because previously this main board had an Intel Pentium MMX CPU installed. To set the multiplier of the CPU to 2, we need to set jumper 3, 4, and 5 in the correct position. So this needs to be in the open on open position. And we also need to change jumper 2 to set it in the 1, 2 position. Again, previously this had an Intel MMX CPU which needed the jumper to be installed in the different position. But with that configured properly, we can boot up the system, and as you can see, it has correctly identified the CPU as the 6x86MX PR200 CPU. Now, this computer already had Windows 98 installed when I inserted the Intel Pentium MMX CPU, but just to ensure myself that the system is running stable with this CPU, I am going to be removing the existing Windows installation by deleting the program files folder and the Windows folder. I had already copied the Windows 98 installation files on this hard drive, so setting up Windows 98 is just a matter of going into the folder and executing the setup command where it will start copying some files around. And I'm not going to bore you with the entire installation, but I just wanted to point out that doing a full Windows 98 installation and having that run successfully already provides a pretty decent baseline in order to determine whether or not a system is running stable. So in this case, I was able to install Windows 98 without any issues, obviously running the CPU at stock speeds, but I am going to be doing the same procedure once I start overclocking this PC, because this is a really good test. If a system is not running stable, chances are you will not be able to install Windows 98 on it without any issues. And with Windows 98 successfully installed, we can start by installing the various drivers that this computer needs and the software that we are going to be using. And one of the pieces of software that I wanted to show you was this Everest Home Edition version 2.2, which gives us some insight in the hardware which is installed in the system, because there is very little information provided by the BIOS or some kind of sensor framework. So we need to find some applications here that are able to inspect the hardware side of things. So here you can see that Everest has detected this Cyrix 6x86MX CPU running at 150 megahertz. It has identified the main board, the video card. And when we go to the overclock section here, we can again see the CPU clock. We can see that the CPU has 64 kilobytes of level 1 cache. The only thing that it doesn't really sense is the actual voltage or front side bus, because there isn't any sensor framework on the socket 7 main board. So although here it does mention the core voltage and the I/O voltage, these are just static numbers. If you would up the core voltage to 3.2, for example, it would still show 2.9 here, which is a bit of a shame. Another popular utility was Hardware Monitor, which uses the Smart Sensor framework to load up all kinds of values like CPU temperature and fan speed. But as you can see, it doesn't find any sensor values here on this main board, so it renders it pretty useless. Another application is CPU-Z. Now this one does find the CPU core speed to 150 megahertz. It doesn't identify the package correctly. It finds very little info on the caches, mainboard, memory, so information is pretty scarce. If you would load this up on a Pentium 2 or Pentium 3, you would get lots more information. And if you use a different version of CPU ID or CPU Z, initially it showed also 150 megahertz core speed, but as I moved the window around, all of a sudden I saw 165 megahertz core speed. It also wrongly identified the bus speed as being 66 megahertz. So yeah, you need to take this information with a little grain of salt, as a lot of these applications won't be able to correctly identify your hardware. So I decided to run Phil's Computers Lab MS-DOS benchmark collection on both the Intel Pentium MMX and the Cyrix CPU. And here you can see the benchmark results. Not a whole lot of surprises here. The Intel Pentium MMX is better in a lot of fields, especially in the 3D department, where a lot depends also on the floating point unit performance. We see the same thing with games like Quake, where the Intel Pentium really pulls ahead of the Cyrix, almost doubling the frames per second that you get in games like Quake and Doom. But it's not all fun and games. Sometimes you want to run serious business application on our Windows operating system. And here we have WinBench 98, which offers us a really nice test suite that we can execute here to get a view on the performance on more traditional Windows-based applications. So here I'm just going to be selecting a couple of tests so that we get a good view of what the computer can actually do and see how it compares against the Intel Pentium MMX. Now, these types of benchmarks would typically use applications which were very popular back in the day. So you will see stuff like Microsoft Excel, Lotus 123, CorelDRAW, Microsoft Word. And it's really nice to see these tests flashing by on the screen. It not only tests the performance of the system, but to some degree also the stability of the system, because if you have an unstable system, chances are you won't be able to complete all of these tests without any errors. And after some 45 minutes of testing, the results are in. Notice how the Cyrix column contains a lot of blue numbers, meaning that it beat the Intel Pentium MMX CPU on this particular test. So let's look at these graphs in a little bit more detail. So here you can see that the floating point performance of the Intel Pentium vastly outweighs the performance of the Cyrix. But on the CPU benchmark, we can see that the Cyrix basically holds up pretty well against the Intel Pentium. And if we zoom in on the more business-oriented tests of WinBench 98, we can see the Cyrix pulling ahead of the Intel Pentium 200 MMX in almost every category. And the same goes for these high-end tests that we did here using stuff like Visual Studio to compile C++ files, or using Adobe Premiere, Photoshop, MicroStation. on virtually all aspects, the Cyrix performed better than the Intel Pentium. Now moving along to 3D Mark 99, which is a benchmark that focuses more on 3D graphics. And here we can see that the Intel Pentium 200 MMX is pulling away from the Cyrix in pretty much all of the tests, except for those where they are evenly matched. We were basically just testing the performance of the 3D blaster. But one of the biggest criticisms of the Cyrix processor was its lacking floating point unit performance. And this becomes very obvious and painfully obvious in games like Quake, which depend heavily on the floating point unit performance of the CPU. Here we can see the Cyrix versus the Intel Pentium 200 MMX, and we can see that the Intel clocks off at over 40 frames per second, while we can see that the Cyrix is still chugging along and will end the Quake time demo benchmark with a measly 21 frames per second. I wanted to show you another 3DFX game because I think it's fair to say that a lot of these games in the 1997-98 era did require a 3D accelerator to offload the CPU somewhat. Lots of games didn't run well at all on both the Intel Pentium or the AMD or the Cyrix CPU using just software rendering. So I wanted to show you some 3DFX games as well, just to show you what the difference in performance is. And here you can see that the Intel Pentium does perform a little bit better than the Cyrix, but I wouldn't go so far as saying that it's unplayable on the Cyrix CPU. Now I did want to show you guys another game, Screamer 2 here, running without the 3DFX support, so running purely on software-based rendering. And here you can actually see that, which was a bit of a surprise to me, that the Cyrix PR200 actually performed a little bit better than the Intel Pentium 200 MMX on this particular game. So I'm not really sure what happened here, because I did rerun this gameplay a couple of times using both CPUs, and on every occasion I had the feeling that the Cyrix performed slightly better than the Intel Pentium. Now, what would be a good conclusion from all of this? Well, to me, I really like this Cyrix CPU. I like the fact that it's like a little bit of an underdog here in this battle against the big Titan from Intel. I really like the Intel Pentium MMX also. This is a real classic workhorse. It just screams stability, it screams quality, but it was double the price of the Cyrix when it was introduced. So yeah, this one definitely was a very interesting CPU for the budget-minded consumer. I also didn't run into any stability issues when running all of these tests and benchmarks using the Cyrix CPU at stock speeds. It was really surprising because sometimes the Cyrix does get a bad rap when it comes to overall stability and performance. But to conclude, I'm really happy to have this CPU in my little retro arsenal here. I think it's a fascinating CPU, and it was also a very important CPU for its time period, not only for the budget-oriented consumer, but also to make sure that Intel and AMD continued on innovating on their CPUs. And I'm not done with this CPU just yet. I will be doing some overclocking on this Cyrix 6x86MX because it wasn't really known to be a very good overclocking CPU, although the MX did improve somewhat in that field. So we're going to be taking a look at that in the next video. So as always, I hope you've enjoyed this video, and if you did, please consider liking it or subscribing to the channel, and make sure to provide any comments you have below in the comments section. So bye bye for now, and I hope to see you on the next one. Bye bye.